Welcome back, guys. It's me, Jaydeep the Spy Kid. So today we're gonna study about types of energy using a ball launcher. So guys, the materials are cardboard. So it's this. Two plastic cups. One wooden or like any kind of plastic ruler. Next, tape, pencils, and these aluminum balls, different sizes, 3 different sizes, and this catapult launcher. So guys, this is my whole project here, as you can see. My hypothesis is I think I can launch the ball without dropping it outside. My variables are independent. I plan to change the distance controlled. I'm going to put trajectory angle the same. And my materials, we already have gone through that. And the test, this is important. So, can launcher be used properly? Is the launcher sturdy? Can it stand up to the stress of repeated launchers? How accurate is the launcher? Are there any changes you can think of to improve the design of the launcher? How easy is it to hit the receiver? How stable is the receiver? So these are all the questions the school or science project can give you, and this is the procedure. So I'm not going to read all of that. I'll just tell you here. So the procedure is like I can put. So guys, this is how my model would look in actual. So this is where the ball is, and that's potential energy, which is initial state, goes into static state, and then potential energy. And then when I put pressure on the ruler, the ball goes into kinetic energy, and here, which is like state 1 force applied to dynamic state, and then kinetic energy. And then it goes into projectile motion with the angle, and then it lands into the receiver. So this is all my readings, my graphs, and the results. Guys, if you don't know what potential energy, kinetic energy, and projectile motion is, I'll tell you. So potential energy is initial state, no force applied, and kinetic energy is the state when force is applied, so when the ball is flying in the air. And projectile motion is right here. Projectile motion is the motion of an object with trajectory. So guys, my independent variable is I plan to change the distance, and control is I'm going to put trajectory angle the same. So that means like the angle that I throw should be the same. And the distance here should be changed. So guys, this is my ball launcher. So this is the catapult. This is the ruler. These are the 2 pencils. These are the cups, 2 plastic cups, and this is my receiver. So, and this is the procedure it took me to build this whole thing. So guys, this is the part when I'm gonna put force on the launcher, and then it should go on the receiver. So guys, this is the second time. Guys, now I put it in here, so I have to calculate the distance. And if you did it, you have to calculate this distance from the launcher to the receiver. So let's try with the second one, or the medium one. Guys, if it's not falling, don't just stay there. You can change the distance a little bit. Yep, I got it. Got the second one. So now I have to calculate the distance from the launcher to the receiver. This is the last one and the smallest one. Yep, I did it in one shot. So now I have to calculate the distance of this one. And guys, I've done this before, so here, these are like my calculations here, the readings and the graph here. So, like as you can see, the first try was 25, yeah, and the second one was 42 or 43, then it went a little higher to 45, then 46. So these are all my readings and graphs. This is calculated in Newton or force, and this is the distance in centimeters. So guys, this is my logbook here. These are my questions. How can you launch the ball without dropping it outside? This is my research. So some things I learned about my topic are the ball needs kinetic energy to launch. Kinetic energy is the energy when you are in motion. Gravitational or potential energy is the energy raised up from the ground. We can learn a lot about how to launch the ball and let it land inside the receiver. You need a projectile motion to launch it. And you guys know about my hypothesis and variables. Independent and controlled. You know the materials too. The procedure, we don't need to go over that. And here's my data collection. So this, as you can see here, this is for one of the balls. And this is all the plannings for here, the graphs, design for the graphs, and this is my two figures. The launcher and receiver with different distances. So here's the launcher, here's the distance. I throw the ball, force, and it lands into the receiver. Yeah, these two are like the same, but we tried it. And here's my conclusion. It says, I studied different types of energy, the force and pressure with the help of ball launcher. The energy changes from one form to another form by applying more force and pressure. So this is what my logbook was all about. So the logbook was actually like this project that we made. If you have any comments or anything, please put all the comments in the comment box, and please like my video and subscribe my videos and hit the bell icon, please. Thank you guys so much for watching my video.